Hello everyone! Today we're going to talk about something a bit different than usual. But I thought this was just also an interesting philosophical topic to talk about. We're going to talk about the beginning of the universe, the Big Bang, or at least I'm going to talk about the Big Bang. I know not everybody believes that that's the beginning of the universe, but I'm just going to talk about what my theory is on the beginning of the universe, how the universe came into existence, and how does the Big Bang work. But like from a very simplified and theoretical perspective. So, also, just to be clear, it's not going to be about a divine creator or something like a god. So, anyone who is religious may not agree with this, but this is not meant as any kind of attack on religion or something. It's just me talking about what I believe in. So I read this book. It is from Stephen Hawking, Brief Answers to the Big Questions. Of course, it's a small book. It doesn't necessarily say a whole lot, but it definitely made me think about this. I'm not a physicist, so it's not going to be about these difficult formulas. It's just me speculating about this. I do have sort of experience with science, as in, I do have a master degree in biology. I want to talk about something that Stephen Hawking says in the book. So, he believes that the universe basically came out of nothing. So some people believe this, that the universe came out of nothing. And before the universe existed, there was literally nothing. When I read that, I kind of felt like it makes sense to me. The thing is, nothing really truly makes sense because, it all sounds weird. It's all difficult to wrap our head around, right? But to me, the idea that the universe came out of nothing, for some reason, it makes more sense to me than the idea that the universe came from a god. Because I always have this question of like, okay, but if a god created the universe, then where did this god come from? You're not answering the question, right? Like, you're not truly answering a question. If you're like, where did we come from? Okay, so a god made us. Cool. But where did the gods come from? Did they just always exist? So if this god always existed, then why shouldn't we? Like, why do we need to come from something if a god doesn't have to come from something? So that's why that answer still confuses me. So he says something that I really remembered. Imagine a man wants to build a hill on a flat piece of land. The hill will represent the universe. To make this hill, he digs a hole in the ground and uses that soil to dig his hill. But of course, he's not just making a hill, he's also making a hole. In effect, a negative version of the hill. The stuff that was in the hole has now become the hill, so it all perfectly balances out. This is the principle behind what happened at the beginning of the universe. When the Big Bang produced a massive amount of positive energy, it simultaneously produced the same amount of negative energy. In this way, the positive and negative add up to zero always. So, what he's trying to say is that technically everything in the universe adds up to zero, so adds up to nothing. And it also makes sense, actually, according to this law that Einstein came up with. This was the thing that, like, energy is mass times something. So, what Einstein basically said was, like, energy is basically the same thing as mass. So, when we're talking about, for example, us, like humans, we are mass, but we are also energy. It's technically the same thing. We are not standing still, we are always moving. Every little cell that we have with all the molecules inside of it are constantly kind of moving or vibrating, or at least they're not standing still, they're doing things, right? We are a moving system. So technically, we are energy. And the idea is this idea of positive and negative energy. adds up to zero. Positive energy is basically just energy and mass, because that's the same thing. So we are positive energy. The things around us are also positive energy. But space is negative energy. Positive energy, like for example, this thing is also positive energy because everything that has mass is positive energy. And you can also think about it like positive energy is movement and negative energy is what we are moving in, which is the same as space. So when I'm moving, there's nothing pushing me back. I can move around in space. And even though what we are moving in right now is not the same as like outer space, it's still space, because we can move, there's nothing stopping us from moving. We have space to move in. So what's going on? There are only two core elements in the universe, and they both add up to nothing. Those two elements are basically movement, also known as energy, and space to move in, also known as space. Imagine if there was no space at all. We wouldn't be able to move, so basically we would not be able to exist. Space is the same thing as time. Space is always expanding, at least right now it's expanding. The universe is expanding and becoming bigger. And this is the reason why time moves forward, why we can never undo what has happened. At the very beginning of the universe, Stephen Hawking says time does not exist yet. Because the universe did not exist, space did not exist, so time did not exist. In fact, nothing happened at all. I had to stop filming, so now we are continuing in the daylight. I talked about the idea of the hill and the hole. When you look, for example, at a tree, you can see it like, for example, the hill. And the space around it is the hole. So imagine this hill, it's created, but it can only exist basically within this space. So imagine the tree, for example, you can just see it as matter. So energy in the shape and form of a tree. And we see it as a tree because to us it has a certain meaning. Because we are human, we look at the world from our own human perspective and we see a tree as something that has a certain meaning to us. And of course, it's very important that we look at things this way and that we see things as different from each other. For example, oh, that's a tree, that's a book, that's a person. Because if we didn't, we would not know how to survive. If we would just look at everything and we would just be like, oh, that's matter, and that's also matter, and that's also matter, then yeah, how do you know what you should eat and what you shouldn't eat? How do you know what you should do to survive, right? It's not very useful to look at things that way. But if we're going to try to be objective and look at things from a non-human perspective, basically, then technically speaking, everything is the same thing, even if we don't want to see it as the same thing. It's like with colors, like you see colors, but you know that colors are not actually real. They're just our interpretation of, well, okay, there are different wavelengths of light, but it's all still light, and our brain needs to decipher that code and kind of be like, okay, that's green, that's red, and etc. Or I can just recognize things more easily if they have a different color, But technically, it's not actually real. And it's the same thing with heat and cold, Of course, we need to know that, like, oh, a fire is hot and we should avoid it. And we should see ice, for example, as cold, because we need to be able to see it as different things in order to survive. It's just movement, but different kinds of movement. Because when something's hot, it's like moving really fast. And when something's cold, it's moving really slow. So the reason why you will burn when something's too hot is because it's literally tearing you apart because of how fast it's moving. And when it's about cold, you freeze because you are not getting movement energy basically anymore. There's no heat transfer, like there's no transfer of movement. You can't move anymore, so you freeze and time stops for you. So I'm also going to, of course, relate this to time because it's all kind of the same thing. So time stops for you because time is movement, and the absence of movement means that there's no time because it means that nothing can happen. And time only means that things are happening, that events can happen, that things can change. It's all about change, you know. When something doesn't change anymore, time has stopped. And the point is, this tree is matter and the space around it is space. And everything else, like the tree, is the same thing as the hill in the other picture. You have to imagine the whole as the universe, right? Space. So the whole universe is that space. And then the hill is all the matter and energy inside the universe, inside the space, which we are a part of. Now I want to talk about what happened at the beginning of the universe. So, obviously, the universe didn't begin with having people and trees and planets and all these different kind of shapes that matter and energy will take on, you know, all these different shapes. So, it started in a very, very small point. Like, imagine a very, very small universe that's not really a universe. Well, we can imagine it as a sort of circle. This is going to become a universe. Imagine nothingness. So around this is literally nothing. This is the moment when both matter and space are created at the same time. This is space, like this outer circle, like that's space. The inner circle is energy or movement or matter. And this will happen because these are opposite energies. So positive energy and negative energy. And imagine that it comes from nothing. First of all, there's only a tiny bit of space created now at this point. It's nothing compared to the amount of space in the universe right now. Because there's a lot of space in the universe right now, but at the very beginning, you can imagine that there was not a lot of space because it was only just being created for the first time, and there was basically the same amount of space as matter. So there was the same amount of space and matter, but nowadays there's more space than matter, okay? So because there was exactly the same amount of space and matter, you can imagine there was a lot more matter than there is right now, which also means that it was very heavy. They call this a black hole, where it's very heavy because there's so much matter in this black hole, even if it's a very tiny, point. There's so much matter because it's all compressed together. There's almost no space. It's like all pushed together. So it's very heavy, actually. Whereas for us, like around us, most matter has some space in between. But here, all the matter is compressed together because there's just a lot of matter compared to amount of space. And there are two forces of nature. One force is the expanding force of the universe. You have to imagine this as like a three-dimensional circle. I don't know if this was the exact shape, but we can just imagine it like that for now. So imagine that from this single point in all directions around it, it's expanding like a balloon that's being inflated. It's going to expand, and that is the force of time, basically. That is the force of negative energy, the force that pushes the universe to expand, which is still happening right now. And then the opposite force, a force that is going into the opposite direction, but because space is expanding outwards, this is a force that goes inwards, which means that it basically explodes. It explodes because of these forces, and then it's just going to all start moving. So all this matter is going to start moving, and it also starts moving. Imagine it moves against space, and then it pushes space to expand. This movement is very, very, very fast because there is a certain force that makes matter or energy kind of attract each other, like gravity, and the other forces of nature, which were unified into one force, basically. But once the explosion happened, this one force slowly started dividing into these 4 forces of nature, including gravity, because over time everything's changing in the universe, and the way that this explosion happened and the way that everything starts influencing each other and moving around is completely random. And imagine if you have multiple universes, whatever's going to happen is random, and in any kind of universe that's being created, something different's probably going to happen. And because of this randomness, this one force starts dividing into different forces and start affecting one another in this very specific way because of how things have moved around and because of everything has changed. But essentially it started with one force, and that's the contracting force. So you had the expanding force and the contracting force. The contracting force makes sure that energy affects energy, basically. It's a force that decides direction of movement. Because if something's gonna move, it has to move in a certain direction. So this is the first direction of movement, where it moved inwards, and then it explodes, basically, and then everything's just moving randomly, but the same force just makes things attract one another and just move in different ways. But that's the moving force, and this is the expanding force that gives us space to move in. And both of them influence each other all the time. Everything moved really fast because this huge amount of matter that's very dense, basically no space at all, has a very strong attracting force to one another. So it's moving very fast. And this is the same thing, but later in time. So if you see this, it looks more like our universe, right? This huge amount of space, and then there's these planets and things moving around. Look at these 2 things, imagine they're planets or something. They're influencing one another, so they might be attracted to one another in some way. And meanwhile, space keeps expanding, because every time that these planets are moving, it kind of increases the rate of expansion of space. Because we are in a period of time where matter influences space, where matter pushes space, basically. Nowadays, there's more space than matter because matter is pushing space. Apparently, there's some evidence that the expansion of space that is accelerating. So it's not constant, it's not a constant rate. It's influenced by matter. So you can say that right now that matter pushes space. So, back to how I said that this was moving really, really fast. So, even now, when we're looking at what's happening right now, time is already moving slower than it was moving at the beginning of time, at the beginning of the universe. Time went very fast, but nowadays time is going slower, and the only thing that means is that the expansion is kind of going slower than it used to, expansion of the universe, and this mass is also moving a bit slower because everything is drifting apart from each other. So, because everything is drifting apart, this planet, for example, cannot be attracted to this planet because they're way too far away from each other. So it's not gonna happen. They're both just kind of floating around without really having any direction of movement. They don't know where to move because the attracting force is disappearing. So, this attracting force that used to be like really strong is becoming almost less and less strong because everything is moving apart from each other. That also means because they are moving slower and slower and slower, they are also not pushing space very much to expand faster. So space is also going to kind of stop expanding so fast. It's still expanding, but it's just expanding a bit less fast than it used to. Imagine there's the same amount of mass as space. So when that's what's going on, it means that this is basically equal to nothing, but at the same time, imagine that if someone could move, or like if mass or energy could move and events could actually happen, then that means that there would be just enough space for the event to happen in and not more. So basically, imagine this person who is stuck in space. So basically, they are standing still, they cannot do anything, which is basically the same as nothing existing because nothing can move, so nothing can happen, so nothing can exist. And time can also not exist. But imagine if you could move and you could, for example, put your arm up and then space would move with you exactly like this motion and it would like bend in the way you were moving, like rubber or something more elastic. In that case, you would be able to do that, but you cannot create space, which means that in the end, space would basically push you back in a way, back into your original position, because you can't create any new space because there's the same amount of matter as space. You would be able to move, but you would always make the same movement backwards so that you end up back in your original position. So technically nothing in such a system, nothing can actually change. Let's see what's actually happening. So this is the reason why there has to be more space than mass, because when mass and space are the same amount, it adds up to nothing. But the whole concept of moving and then moving back again is basically the concept of our universe, I believe, and I'm going to elaborate on that later. But for now, let's look at the fact that things moving around freely, where they can basically choose their own path without being confined in space, without being stuck in one place. It's like I said here, you can't move around, you're stuck there. But if you want to be able to move around and not be stuck, you need space to move around in, and you need more space than the movement you're going to make. So for time to even exist, there needs to be more space than matter. And you would think, like, how does this add up to zero? Because there's more space, so it's not the same amount of energy as space. So rather than nothing, there's something here, because if you add everything up, there's still this excess amount of space. So you still end up with something. Because the whole idea of a black hole is that it's literally actually nothing, because there's nothing inside it. People say that there's something inside it because they say that it's a lot of energy and mass that's very dense and heavy, and this energy has basically no space to move in. But in the end, in such a black hole, time stops. If it can't move, then nothing can happen inside a black hole. So you would say that time stops. And in reality, like here on Earth, for example, you won't really find a black hole because nothing is so dense that time can actually stop. Like most things here are not that dense, you know, you don't really literally see that a lot. So, and there's not only small particles moving around, but there's like huge, like planets and that kind of stuff where it all sticks together. And it's possible because of this force keeping them together, right? And we have to remember that the whole universe, that it's a dynamic system and it's always going to be a dynamic system. Because these energies are moving, they're just moving in different directions. But they are always moving. So, yeah, imagine this is the universe. We're thinking about the far, far future, where the universe has gotten really big. And what's going on? Everything's moving further and further apart from one another, which means this attractive force just becomes weaker and weaker. Because imagine at the beginning of time, when this whole force even started, it was just a singular point. So it was all kind of really, really close together. So when things are really, really close together, they will show the strongest force possible, which you will also see in a black hole. Because what a black hole does is basically whenever anything comes close to it, it just sucked into it, you know, because it's attracting everything around it to become part of the black hole, basically, because of this strong force going on. So imagine the opposite of a black hole is when all matter is just kind of randomly distributed through space, where they're so far apart that the force is too weak to really do anything, because the force is so different from what it used to be. And at the end, that means that we will get to a point where time goes so slowly that the situation will reverse itself. Why does the universe exist in the first place? Like, if there was no God, or is no God, or anyone, or anything that decided that it was going to happen, or that kind of caused it to happen, because cause and effect did not exist, then how on earth did it happen, right? Stephen Hawking gave the explanation of how can something come out of nothing, and his explanation was quantum mechanics. Now, not everyone agrees with his explanation, because quantum mechanics is just a certain law, you know, which says that, oh, particles can just appear out of nothing. The thing is, if this law even exists, then that means something still exists, right? And if a particle can appear out of nowhere, then that still means that something has happened, that an event happened. So I personally don't really agree with his explanation of it being quantum mechanics, because I don't see it as possible that anything could ever come out of nothing, because nothing can happen if time does not exist. So now I want to talk about a different explanation for this. There are some people who say that the universe will start contracting at some point, where it will stop expanding and it will not expand anymore, but it will shrink and become smaller and smaller, almost like everything is going to be reversed. They call this the Big Crunch, which is a bit of a strange name, but we'll go with it. Basically, at some point in time, the universe will start shrinking. And I personally believe that this makes a lot more sense than the theory that the universe will keep on expanding forever. The idea is that time will start moving slower and slower and slower, but can it stop? It won't stop. Time will keep moving slower and slower and slower until it reverses, and then we come into an era where like this, space starts pushing matter back instead of matter pushing space. So the exact opposite would happen. And if this theory is right, then that's going to happen somewhere far in the future when maybe we don't even exist anymore, but then space starts pushing matter, and what it's doing is time is slowly reversing. It starts going backwards. Time would actually start going backwards because space will literally just push everything that happened back into its original place where it started. Just like the person who was like pushing their hand through space and then it's being pushed back. Space would push everything back in its original position, which means that time would be moving backwards instead of forwards. And we, as matter, don't have a say anymore. We can't do anything anymore because we are not pushing space anymore. Space is pushing us back. And then what happens is that as the universe becomes smaller and smaller, matter is going to just, also go closer together like it originally was in this very, very dense, heavy point or black hole. So in the end, we would end up with the exact same starting point of the universe, and then it will be nothing again. So now I just want to write down this very simple equation. So Stephen Hawking said something like, okay, 0 becomes 1 because the universe, which is basically something, the universe, which is something, came out of nothing, so 0. So how did 0 become 1? So now I want to propose a different explanation of something did not come out of nothing because it did not actually happen. Okay, so -1 is when the universe is literally disappearing again. Like we have the 1 era, which is the era which we are in now, where something exists, minus something, which you might think like, okay, that's not the case because we exist, but what if everything is going to disappear in the future? What if we are just in the in-between? And there's 3 phases, and the first phase is, imagine this is the attractive force. Well, let's say positive energy. The positive energy is greater than the negative energy. So this is matter, this is space, right? But when we're talking about energy here, the idea is that this positive energy is pushing space to expand because there just seems to be more positive energy than negative energy at this point. Then at some point when we end up here, all this positive energy is now stored in space and it will start moving backwards. The universe will start shrinking down. We end up in this phase where here is like matter is pushing space, and here's like space is pushing matter, because all this huge amount of negative energy is now pushing matter back into its original place. So it's really kind of all about this energy conversion, and in the end everything has to add up to nothing, which is the third phase, which means that the 2 forces are perfectly balanced out. And this is only at the beginning and at the end of the universe the case. But once the universe has started to expand, it's out of balance. But then once it will end, it will be back into balance again. Where again, this is nothing. So, and this is not a dynamic system. This is just where nothing can happen, where time does not exist. And here time does exist, just in two different ways, where it's still a dynamic system, but it can move in two different ways. This is the Big Bang, and this is the Big Crunch. But I just said that the blue one was space, but it doesn't matter. It's just that one is the Big Bang, of course. That's what's happened in the beginning. And in fact, it's still happening. It's just happening a bit slower, than it used to be at the very beginning. This is the Big Bang. This is the Big Crunch. And this is the nothing. So this is the beginning and the end. But yeah, who knows? Maybe this is the truth, and in that case, then it would also mean that our existence is pretty pointless. But at the same time, I always feel like as long as it has meaning to us, that's the most important thing. It doesn't matter if we mean nothing to the universe. And in that case, the laws of nature are basically laws that aren't created by a creator, but essentially there's only one law, and that law would be that, well, that law would be that everything is basically the same thing. So that would be the only law of nature. So I try to explain this as clearly as possible, but of course this whole theory is super confusing. But I just try to explain it in terms of how I understand it right now. If you managed to watch this whole thing, thank you for watching and listening to it, and I hope to see you next time. Goodbye.